So this is the problem we did in class today. And so the answer is, well, let's take it one step at a time. What does MCPBA do to that alkene? It's going to generate an epoxide. Now you can draw it like that if you'd like, but you have to understand that there is stereochemistry involved. And so if I draw the wedge, it would look like this. And it's good to show some stereochemistry because when we treat it with step 2, we have a Grignard reagent. And so that's going to look like this, MgBr, and that's going to come in and pop open that epoxide. And so if the epoxide is a wedge, then we would have to have the Grignard approach from underneath. So there's our methyl, and then our alkoxide right there. And step 3 is just going to be a proton transfer to generate your alcohol, like so. Now, step 4 is phosphoric acid, which is going to tack on a proton there, which converts that into a good leaving group, and then eventually we get a elimination product. We're going to get this one because it's the most substituted alkene. Then we're going to treat that with MCBBA again, and we will form another epoxide. And let's say it approaches from the top face or the front face. So that would mean the ethyl group is a dash, like so. Now, we treat that with sodium bromide, which is a salt, which means our bromide is just a negatively charged anion. And so now we have to go back to the reactions of epoxides. When the epoxide is neutral, does the nucleophile favor carbon 1 or carbon 2? When the epoxide's neutral, it's going to go to the least substituted side. And so then we would have our bromine attack there. So what would that look like? The ethyl is still a dash, and then the alkoxide is like this. And then the bromine came in from the other side. So now we have that species. And then we'll have a proton transfer. And we can just kind of well, if we leave it at that, what's going to happen now when we add some more base to it, it's going to do a second elimination. And we're getting a little messy here. Okay. Well, what if I say, let's put some product solvent, let's say water, something. It doesn't really matter. Proton transfers are easy to come by. So we'll just say we have an alcohol, okay, after step 6. If you did an alcohol or an alkoxide, I would say both are good. Now step 7 is adding a base, and so we have some heat, so that's going to promote an elimination. And so that would give us, let's see here, what would that give us? An elimination that looks like this. Okay. We're going to eliminate off that bromine. So that would be our final product at the end of that reaction sequence. The other problem that we took a look at was looking at an epoxide and figuring out the configuration. And so we need to find stereocenters. That's a stereocenter and that's a stereocenter. So when we do this, let's do the one on the left. So we have to prioritize the groups. We have, let's just circle them. We have a hydrogen. Here's a group, a methyl. that piece, and that piece. So there's 4 different groups around that stereocenter. That's why it is a stereocenter, right? Okay, so now we just prioritize these things. The hydrogen's going to be priority 4. Oxygen will be priority 1. And then we have this methyl, and then this carbon right there. And that's going to be priority 2, priority 3. It's going in the clockwise direction, so that makes that R. Now if we redraw this, and then look at the other one, what do we have here? We have priority 1. Let's see, now we have, whoops, we have our hydrogen coming off as a wedge now, that's priority 4. So now it's between this carbon and that carbon. And this one's going to take priority. And that's 3. So that goes in the counterclockwise direction, which should be an S, but we realize that the lowest priority is a wedge, so we have to take the opposite. So that would be a R. So both of these stereocenters have a R configuration.